Hello everyone, and in this video we're going to be looking at simplifying trigonometric identities. Okay, in particular with a focus on A2. So here's a really good one for question 1. We've got to prove that cot cosec over sec squared plus cosec squared is equal to cos cubed. Now, the right way to do this is to either start off by writing left-hand side equals, and then step by step changing it until it equals the right-hand side. Or you can do it the other way around and start off with the right-hand side. But most of the time, it works out best if you start off with the left-hand side. So the left-hand side is cot theta cosec theta over sec squared theta add cosec theta, cosec squared theta, cosec squared theta. Okay, now the first thing that we need to do here is to change the identities so that they're written in terms of what they actually are. So they're not written as reciprocal trig identities. So cot is 1 over tan. Okay, cot is 1 over tan theta, but 1 over tan theta is 1 over sine theta over cos theta. And 1 over sine theta over cos theta is cos theta over sine theta. Okay, so basically we can replace cot theta. It can be rewritten as cos theta over sine theta. So that's our first step. Cosec is 1 over sine. So we write that as 1 over sine theta, like so. So that's the numerator done. And then the denominator, let's think about that. We've got 1 over sec squared, and 1 over sec squared is 1 over cos squared. So 1 over cos squared. And cosec squared is 1 over sine squared, so we can write that as 1 over sine squared. So there you go. So our first step is we've replaced all of the trig identities with, just in terms of regular trig, we've got rid of the reciprocal trig identities. Now let's look at our numerator. Our numerator is cos theta over sine theta, and that is times by 1 over sine. So that is cos theta over sine squared theta. Okay, so that's our numerator. Now, the denominator, whenever we've got something add something in the context of these trig identities, usually it's extremely helpful for us to combine into a single fraction. So whenever you're simplifying or solving a trig identity, you always want to be like reducing it into a single fraction, okay? So what I'm going to do is multiply the numerator and denominator of this one by sine squared theta. And we're going to multiply the numerator and denominator of this one by cos squared theta, because we're trying to get a common denominator. And when I do that, bringing that together, I end up with sine squared theta add cos squared theta all over sine squared theta cos squared theta. So usually when you combine them into getting the whole thing over one fraction, you'll very often find that something really useful happens. And indeed, that's the case here. Something very useful is about to happen. And what that is that sine squared add cos squared is about to become 1. So sine squared add cos squared is 1, okay? So this is now cos theta over sine squared theta all over 1 over sine squared theta cos squared theta, like so, okay? And that's good. Now, basically, this is really good that we've got this, because now we've got the format A over B over C over D. And whenever we have A over B over C over D, that is the same as A over B times by D over C, okay? So basically, when you've got a quadruple fraction like that, you take the reciprocal of the lower one and you multiply it. And that's what we're going to do here. So this is now cos theta over sine squared theta. I'm going to times it by the reciprocal of this, which is going to be sine squared theta cos squared theta all over 1, like so. And this is super useful now because our sine squareds are going to cancel, leaving us with cos theta times cos squared, which is cos cubed theta, which is in turn equal to the right-hand side. And there you go, step by step, we've started off with the left-hand side, and we've, through a series of steps, have shown that it equals the right-hand side, which I think would probably be worth, I think that'd probably be worth somewhere between 3 and 4 marks if that was an exam question. Okay, good. Now, the next bit, let's have a look at part B. Okay, part B, it says this often would be worth just a couple of marks at the end, maybe 1 or 2 marks. Part B, it says, hence, explain why the equation cot theta cosec theta over sec² plus cosec² equals 8 has no solutions. Now, for these part Bs, what you need to be thinking about is what's the link between part B and part A? And the link between part B and part A is that this expression here is cos³. So we're going to write that as cos³ theta equals 8. So we're using what we derived in part A and applying it in part B, which is quite often what happens. Now, if we cube root both sides of this, we get that cos theta is equal to 2. And hence, there are no solutions, because we know that cosine only goes between 1 and -1. So cosine theta equals 2, there's going to be no solutions. And that's part B done. Perfect. Let's have a look at the next question here, question 2. So question 2, what have we got? Okay, again, this is a simplify, this one. Okay. Oh, no, it's another show that, sorry. It's kind of a show that the left-hand side equals the right-hand side one. Okay, so let's have a look at this. So again, we're going to start off with the left-hand side. I'm deciding this one, it's really clear that we should start off with the left-hand side because remember I said to you we can combine these fractions. You wouldn't want to start with the right-hand side because you'd have to try and reverse engineer sec into that, which would be extremely challenging. So we're going to start off with the left-hand side. Okay, so the left-hand side is cos x over 1 minus sine x plus 1 minus sine x all over cos x. Perfect. So step 1, as I've advised previously, is we're going to try and think about getting the whole thing over a common denominator. Okay, so I'm going to multiply the top and bottom of this one by cos. So that's going to give me cos² x over cos x times 1 minus sine x. And then this one, I'm going to multiply the numerator and denominator by 1 minus sine. So I'm going to have 1 minus sine x all squared over cos x, 1 minus sine x. Okay, so basically what we've done there is we've just got a common denominator. So let's combine these now. So we've now got cos² x plus 1 minus sine x all squared all over cos x times by 1 minus sine x. Perfect. All right, where are we going to go from here now? Well, let's expand this 1 minus sine squared. So 1 minus sine squared, so we're going to have cos² x plus 1, and it's going to be minus 2 lots of sine x when we expand it, plus it's going to be sine² x. And that's all over. I might leave that. I'm not going to factorize. I'm not going to expand that. I'm going to leave it factorized. Cos x times 1 minus sine x. Very often it's more useful to leave the denominator not factorized, not expanded rather, to leave it factorized so that we can cancel stuff out. Okay, how does that help us? Actually, that is pretty useful because what we've got now is we can see that we've got a cos² add sine², which is going to be 1, and we've got an add a 1. So that's going to go to 2 minus 2 sine x, making use of the fact that cos² add sine² is 1. Okay. So now what we're going to do is, that's really useful because we can take out a common factor of 2 here and rewrite the numerator as 2 times 1 minus sine x. So 2 open bracket 1 minus sine x all over cos x times 1 minus sine x. Okay, well that's great because the 1 minus sines cancel and we're left with 2 over cos. But 1 over cos is sec. So this is 2 sec x, which equals the right-hand side. And that's that one done. So remember, the most useful piece of advice I'd recommend on that one, the one that I call question 2, is to combine it to get it over a common denominator. Lastly, let's have a look at one more in this video. So question 3, we've got to show that this one, arguably, you could start either with the left-hand side or the right-hand side, but I'll start off with the left-hand side just because that's a lot of the time it is the left-hand side. Again, there's no right or wrong way. You could equally just start off with the right-hand side and get to the left-hand side. That would be also totally valid. Okay, so what have we said previously? In previous videos, we've said let's replace the reciprocal trig identities with their regular equivalents. So we're going to write that cos theta is 1 plus, and if it's okay with you, I'm going to go straight in and think about that as cos over sine theta, as we discussed earlier in this video. Okay, so what cot theta is cos theta over sine theta. Now this introduces another interesting little thing. Whenever you've got like a fraction within a fraction, okay, here we have a fraction within a fraction. Usually, if you multiply the numerator and the denominator by whatever it is that's causing the whole thing to be a fraction within a fraction, then that can like really help us simplify the whole thing. So let's do that. So we're going to multiply everything by sine theta, just because that's what's causing us to have a fraction within a fraction. Okay, so that's going to give us cos theta sine theta over sine theta plus cos theta. So now we can have a look at what we're aiming for. And how does this compare to what we're aiming for? Well, it's kind of like getting there. Notice that we've just got a sine in the numerator of what we're aiming for, and we've got sine cos. So we're going to divide now every single term by cos. Let's divide, rather, we're going to divide every single term by cos. And remember, you don't change the value of a fraction as long as you divide every term by the same thing. So I'm going to divide this by cos, which is just going to leave me with sine. I'm going to divide this by cos, which is going to give me tan. And I'm going to divide this by cos, which is going to give me 1. And now I've got sine theta over 1 at tan theta, which equals the right-hand side. Now, another point that's worth mentioning is that in these trig identities, you know, there's lots of ways that you can do it. I chose to do it that way. An alternative approach for this particular one is I could have thought of this as cos theta over 1 add 1 over tan theta. And I could have carried on there and proceeded down that way and got to the answer as well. But I just chose to do it this way. There's very often multiple correct ways to do this. Perfect. Well, that's an example of simplifying trig identities with reciprocal trig functions in. I hope that you found that helpful, and I will see you in the next video.